Hi there, my name is Charles Wells. This is a presentation on solving systems of linear equations using matrix inverse. Okay, we are asked to consider the following system of equations. That's right, which is actually was our first chapter we discussed, but then after that we did vectors and then matrices and all those things. So you must see that these things are interrelated. When we're dealing with matrices, we're dealing with system of equations, there are always some vectors somewhere around there. Like for example now, here we're asked to change this system of equation to write it this way. We're supposed to write it as AX equals to B. X, this X and the B are actual column vectors. Like for example, we can take X here is supposed to be X, Y, Z. You cannot confuse this X and that one. This is an entry of a column matrix, and this is the name of that matrix. And this vector is a vector in R3. Everybody knows that, isn't it? So you can say that is a matrix of unknowns. That's right. Okay. So then B is the same type of vector. Now, how do we change this system of equations like this? This is a system of linear equations. It's got one equation here, two, now a second equation, and a 3 for the third equation. So we've got 3 equations and the 3 unknowns. That is clear. Is that clear to everybody? Okay. So now to take this to this form, we need to undo the multiplication of matrices here. What do we mean by undoing multiplication of matrices? What we have got on this side of the equation is actually a result of multiplying the matrix X with some matrix A, which we can see if we know what we're doing, but it's maybe some people are not very clear what it is there. But let's do this. If from every row here, 1, 2, 3 rows, we remove X, Y, Z, and put it this way, like it's said here, X, Y, Z, because X represents the matrix of the unknown, and then equals to 2, 3, minus 1. What will be left inside here? You can tell me. I said I've removed the X, Y, Z. What will be left inside? Come again? 1, 1, minus 1. That is, we're moving along a row, isn't it? Okay. Right. Isn't it? That's 1 there. Then we've got 3, 2, and minus 1. And then we've got minus 1, 2. I heard somebody talking about the 3 here. I don't know where the 3 is. Okay, it's invisible. No, it's just a mistake. Okay, somebody crossed the bridge before you were supposed to cross the bridge. Okay, it's fine. Right? So, that's the thing. You have seen it? That's the first question they say is, take this matrix to this form, and then we have already written X is that, and A is this, and then this is the matrix of the left-hand side, right-hand side. So now what's the next question? Next question is, what are the respective sizes of the matrices? How do we give sizes of the matrices? The next thing is, what are the respective sizes of the matrices? Sometimes people use this word size, sometimes people use the type of matrix. You can say size, I don't know whether they want to say size of A. The size of a matrix is given in terms of its rows and columns. Did you hear what he said? He said the rows and columns. He didn't say columns and rows. That's very important. The order there is very important. Rows and columns. So the size of A, we must mention the rows of A, say by the columns of A. Altogether. So now what is the size of A? 3 by 3. So that is 3 by 3. I don't know whether I'm wrong. I'm seeing the size of X equal to the size of what? I'm seeing the size of x being equal to the size of p. Size of p. 3 by 1. We're being asked here to find the inverse of a. This is how to denote the inverse of a. A power minus 1. And we read it as inverse of a. We see this, we read inverse of a. So now let's see, for the benefit of those who are not here when I presented this for the first time, what is this inverse of a? It's another matrix. But now, what is special about this matrix is this thing. Look at this equation. 2x equals to 8. If I were to solve this equation, I would need a number, another number. And that number actually is a number which when I multiply it by 2, I get 1. Then I've got 1x equals to something. But when I multiply an equation, I multiply both sides, isn't it? So that number is 2 to the power minus 1. And this is 2 to the power 1. And then this is x. And then I say equals this side 2 to the power minus 1. And the 2 to the power 3. So then here, when you multiply this 2, we're going to get 2 to the power 0. And 2 to the power 0 is equal to 1. Then you've got x here. Then you've got here 2 to the power 2. And then we're told that x is equals to 4. All together. Now coming on this side of matrices, we've got the matrix here as, we've got the system of equation written as a x equals to b. Now notice here, when we multiply these two, we got 1. And the 1 multiplies any other number, like x is standing for a number, we get what? X. Then we say 1 is an identity for multiplication. So then, what happens here? The inverse of matrix here must behave exactly in a similar fashion. What is going to happen? It's going to happen that when you multiply here by inverse of a and multiply by x, it will be the same as multiplying here by inverse of a. Now what's going to happen here? We're going to get an identity here. An identity matrix. And since we're dealing with a 3 by 3 matrix, we're dealing with 3 by 3 matrices, our identity is like this. Now we must see that this identity, when we multiply it by any matrix, we are going to get that same matrix. So then now, if we're multiplying this identity by this x, we're going to get x. But you know what x is? X is, and we know here, if we're multiplying a 3 by 3 matrix by a 3 by 1 matrix, our answer, please pay attention to what I'm saying. If we're multiplying a 3 by 3 matrix and a 3 by 1 matrix, our answer will be a 3 by 1. Here, when we multiply there, we're going to get a P1, a P2, and a P3. This is what we're going to get. I haven't started doing the problem. I'm just trying to explain to you to try to see how what I was doing here with numbers is similar to what I'm doing here with the matrices. Now, when we get these two, these two things here, we've finished multiplying on the left, we've got x, y, z. We've finished multiplying on the right, we've got P1, P2, P3. So now x is equals to P1, y is equal to P2, and then z is equal to P3. All together. So now to solve this solves the system of equation according to what they are saying. They're saying we must solve it by using the inverse of matrix. What does it mean? It means 1. So let's say initially we transform the equation to a, x equals to b. Number 2, we need to find the inverse. Number 3, we multiply both sides of 0. From there, we multiply both sides of 0 by a to the power minus 1. Then that will be equals to a to the power minus 1 multiplying what? B. Where will this get us? It gets us to step number 4, where this is an identity. Then we multiply an identity by x, we get x. And we know x is x, y, z. I'm saying X, X, but I think you know that here when I'm saying X, I'm talking about capital letter X, isn't it? Which is the name of this matrix. And at this side, we're going to get B1, B2, B3. Then once you have done that, step number 5, you've got now to declare that your X is equals to B1, your Y is equals to B2, your Z is equals to B3. You're done. I haven't solved the problem. I'm just trying to give you a roadmap of what you do. Altogether. So the biggest task here, there are 2 tasks here. The biggest task here, I think, is to find this. The next task is to do this multiplication. The initial task, which I don't find it very difficult, is to write the equation in matricial form. When the equation is in this form, this equation taken to this form, we say it is in matricial form. Matricial form. I'm not sure that the spelling is correct, but you can check that. I think this is correct. It is equation in matricial form. Now, can I ask a question? Do we now all know what we're supposed to do? I'm not saying do you know how to do. I'm saying do you now know what exactly we're supposed to do? Okay, so now let's start doing it. Let's start doing it. The method we're given here is we're supposed to find the inverse by using this kind of transformation. I'm not even doing the thing, I'm just explaining what I'm going to do. That's all. This what I've written here is just like an argumented matrix, which is got row 1, row 2, row 3. Do you have a question to ask me there? I think we know A. Yes or no? We know A. Do you know A? What don't we know there? What don't we know here in this setup? What don't we know? Do we know everything? Do you know this? This one, isn't it? So we know everything, isn't it? So what are we going to do? We're going to use row operations to transform this. We start here, we transform it using row operations until we get to a situation where we've got something like this. What do I mean there? You do I'll show you what to do row operations, but just know that you will do something from here down until you get here. What will be there? The same identity. What will be here? A new matrix, which I've called B here. If we've done it correctly, B will be equals to A inverse. Do you understand what I'm saying? I'm saying we'll start with this matrix A with the identity and put them this way. Name the rows from row 1 to row 3. Do the transformation. Do the transformation. As you transform here, this A will evolve. If you understand what I mean by evolution, it's going to evolve until it is eventually transformed into an identity. And this identity will also undergo some evolution until it's transformed to some B. If that is done correctly, B will be the inverse of A. And then once you've got the inverse of A, what are you going to do? You can pass to step number 3. Do the multiplication. I hope I don't know, but I trust that I've shown the road what to do. Then now we're going to engage with how to do it. Now let's present this equation in a matricial form here, and then let's have our identity matrix very clear to everybody. Okay. So now we want to have this setup. This is just a line which shows that we've got 2 matrices there, and we've got that and that. Now let's write this. What are we going to do? Then I go row 1 and row 3. So then what I'm going to do is we're going to rewrite the first row 1. Now listen carefully. Remember what we said. We said at the end we want an identity here. Altogether. Which means in this position we're going to need a 0. In this position, I'm going to need a 0. In that position, I'm going to need a 0. That is the first time. In this case, now we're moving in this direction. We're targeting to have a 0 here, a 0 there, and a 0 there. Are we together, guys? Yeah. Now, this is what we're going to do now. Let's write now row 2. What do I mean here? I mean, I'm going to have a new row 2, but this row 2 is going to come from a certain operation I'm going to do with these rows. I need a 0 here. It's me. That's how I work. If I know that I need a 0 somewhere, I put it. Then I ask myself, how am I going to get it? So I see here, I've got I've got 3 here, I've got 1 here. What comes to my mind first is that I'll multiply row 1 by minus 3 and add row 2. I'll just check whether that gives me a 0 only in that position. So 3 there, minus 3 there, plus 3 will give me 0 there. All together. Please notice one thing. You cannot try to achieve row 2 and not involve row 2. All together. And whenever you are trying to get row 2, you must know that you use row 2 and any other row of your choice. All together. Okay. Somebody else could have chosen this one and multiplied. This would be the same as multiplying the first row by 3, the third row by 3, and adding row 2. You will see that that will give us a 0 there. All together. Are we there? Okay. So now, once you've got a 0 there, then you can just repeat the same thing all throughout the row. Now we come here. Minus 3 there, plus 2. If I'm not correct, you correct me. It's minus 3 there. I'm using this one. Minus 3 there, plus this 2. That's fine. Minus 3 there, I get a 3. Plus minus 1. This is a minus 1 times minus 3. It's going to give me a 3. I add a minus 1. And then there I get a minus 3. And then I add a 0. There I multiply by minus 3. Then I add a 1. There I multiply by minus 3. I add a 0. All together. Then we need a 0 here. I will need a new row 3. And that row 3 must come from some operations with the rows involving row 3. All together. Can I have a suggestion? Someone say, let's take row 1 plus row 3. Let's see. Row 1 plus row 3, get a 0. And there a 0. There a 1. This is what? This is minus 1 plus 2. It's a 1. Isn't it? Then here a 1. Isn't it? And there 0. And there a 1. All together. Then we continue. Actually, what have happened? We have achieved this. If you see what has happened, we have achieved that. Do you see that? So now we need to achieve zeros at the top. Now what I'm going to do is, let's write this way. Now I'm putting this arrow here. Because I've finished to get, I've achieved to get zeros here. And now I want the zeros where? In the upper. Now I'm moving upward. Now moving upwards, listen carefully. Moving upwards, I'm going to copy my third row as it is. I copied my third row as it is. Now I'm moving upwards. Because there's nothing else I'm going to achieve down here on this row. I've got the zeros I need in this row. So now I'm moving upwards. Are you sure, convinced? Why did I arrive at row 2? So this arrow has nothing to do with rows. It's just showing us that not in row 1, we've got this. We have zeros there. Okay. So the arrow has nothing to do with rows. It's just indicating the direction in which we're moving. So now this is row 3, row 2. Now I need a new row 2. In that new row 2, check. In that new row 2, I only need a 0 here in row 2. You see that? I need a 0 in row 2 here. We're going to need a new row 2 there. How are we going to get it? You decide. No, that's not going to work. We need a 0 here. I didn't get that. Row 2 minus 2 times row 3. So we definitely can get a 0 there. Altogether. Then we repeat that with every row. Isn't it? Now if we multiply here, row 2 minus 0, we're still going to get minus 1. Altogether. If we multiply here, row 3 by minus 2, and this one is still row 2, we're going to get a 0. Altogether. Then we come this side. We've got minus 3, row 2. And then we minus this, that's minus 5. Do you see that? It's minus 3 here. We multiply by minus 2 here. we're going to have minus 5. Are we there? Yes. Minus 5. Can you please try to nod when you think it's right? Then you can shake your head if you think it's wrong. Because it looks like your mouths are very difficult to move. It's minus 5 we get there, is it? So now we come here, you've got a row 2 here. We multiply this by minus 2, we get a 0. Then that is still going to be 1. And then here, we've got row 2 here. We multiply this by minus 2, and we add. I think that is going to be minus 2. Yeah, with this minus 2 plus 0, it's minus 2. We're multiplying row 3 by minus 2. This is minus 1 times minus 2 plus a 0. Is that right? Okay. Then we go to row 1. We need a new row 1, but that row 1 is up to us to choose. Do we start with this one or we start with that one? Where do you want to create a 0 first? Do you want to create a 0 there or a 0 there? This triangle is covering zeros. It's guiding you. I've already told you. Look at this. Look at the guiding thing is this one, the identity, because you said you want identity at the end. You said this thing must be transformed to get to somewhere where we've got an identity here and some matrix B here. That's what I'm doing. Are we together? So now where do you want to start the 0? Do you want to start the 0 here? You cannot, listen, you cannot get 2 zeros at one go. If you get them, it's coincidence. But at the moment, you must target 1 0 at a time. So tell me which 0 do you want to get first. Which one? Second column. So how are we going to get it? If you need a 0 here, how are we going to get it? Row, you see guys? Row 2 plus row 1, we get 1. Row 2 plus row 1, we get 0. Row 2 plus row 1, we get 1. And then, that's all in there? We get 1. Then we say row 2 plus row 1, we get minus 2. Then you get a row 2 plus row 1, you get 1. Then you get row 2 plus row 1, we get 0. So okay, I think that was a good operation. We've got there. We've got the zeros we want. We are left with this entry here. Do you see that? We're left with this entry. So we need some more space here. Let's do this. Now because we've got all the zeros we need in row 2, we've got all the zeros we need in row 1, we copy row 3 as it is. Did you hear what I said? Now here, because we need a 0 here, we're now going to make a new row 1, and that we must decide now how we're going to get that new row 1 with a 0 here. So since we need a 0 here, I'm going to put it. Immediately I'm going to put it. I will put it to one place, then decide on the operation I'm going to do. Then I do the whole operation everywhere. What am I going to do? Row 1 minus row 3. All together. Okay? So if you say row 1 minus row 3, you're going to get 1. Row 1 minus 0, you're going to get 0. And here we've already got 0. That's why we decided on this operation. Then here what is row 1 minus row 3. We're going to get minus 3. Row 1 minus row 3, we're going to get 1. Row 1 minus row 3, we're going to get minus 1. Are we together, guys? Okay. Now we need one operation to change this thing to identity. What is the operation? This is not identity. This is not an identity. So we need one operation to get the identity. What do we do? We multiply row 2 by negative 1. How together? Multiply row 2, negative 1. So let's do it this way. Let's open some space here. We know how we got that. We've opened some space there. We want to do exactly what you are telling us to do. We're going to operate with only one row, and then in this case we got row 1 here. Row 2 will be a new one. coming from minus 1 times the same row 2. Altogether. Then row 3 will be the same row 3. Then we just copy that. 1, 0, but 0, minus 3, 1, minus 1. 0, 1, 0, minus 5, 1, minus 2, 0, 0, 1, 1, 0, 1. We didn't not that we didn't multiply here. We should multiply this by minus 1, and here minus 1, then here it becomes that altogether. So this is our, this is supposed to be, let me put the division again there, and then this is supposed to be our A inverse if we did correct, and there we've got our identity, which is exactly that kind of setup. So up to this point we have managed, we can suppose that we've managed to get an identity here, and what we've got here is the inverse of A. But I'm putting a question mark there. Why do I want to put a question mark there? I want to put a question mark there because I want us to check that is correct. Obviously, maybe writing a test or exam you might not be able to check, but trust your calculations that are correct altogether. But now you've got time, we can check. Let's check whether it's really an inverse. Can you copy that matrix down? You don't have the matrix. We do. So give me the matrix here. This matrix, you don't have it. You do have it. So give me the matrix. Yeah, this matrix is, we suppose that is an inverse, né? Then what is this? So this is the matrix we got on the right hand side, and we suppose it's our inverse, isn't it? Then let's have our matrix A right now. So what do we do now? We are multiplying these two to check this where it gives us identity. All together. Okay. So now let's multiply. Inverse multiply by A. And here it doesn't matter whether I say A by inverse, its inverse, or say inverse by A. It's the same thing. You can even do it this way. Because you know normally that when you multiply matrices in one order, it doesn't mean that it is the same when you multiply in the other order. It's not like 2 times 3 is equal to 3 times 2. Right. At this moment, I would advise you to put your pens down, especially those people who don't know how to do this thing. If you don't know, you better see first how it's done, then try to imitate what is being done. Altogether, note that this is a 3 by 3 matrix, and this one is also a 3 by 3 matrix. What it means here is that the number of columns in this matrix is equal to the number of rows in that matrix. When that happens, when those two numbers, you put two matrices next to each other like that, you see that these numbers are equal. That tells you that you can multiply. And then these two numbers here, they tell you that your answer is going to be this by that. So you are going to multiply by 3 by 3, and you are going to get a 3 by 3. Did you hear what I said? Now let's do the multiplication. How do you do the multiplication? Look, take this row as a piece. You lift it up until it's here. Then you rotate it anti-clockwise. In other words, it's standing like this. You tilt it to the left anti-clockwise. What we're going to see, this 1 is going to fall on 3. This 3 is going to fall on 1. And this minus 1 is going to fall on minus 1. Do you agree? Huh? Because once I lift it up like this, and I let it drop to the left, it's going to look like this. Then once it's like that now, what do? I let it go through all the rows of this matrix, downwards. So it's going to come and visit this, visit that, and visit that. Each time it's visiting this one, that one, what will be doing? The corresponding entries, those which come together, they will be multiplied. Those which come together, they will be multiplied. Those which come together, they will be multiplied. Now let's see what I'm going to have. I'm going to have minus 3 dot 1. That's multiplication, the multiplication. Then 1 dot 3. Then minus 1 dot minus 1. Once that multiplication is done, the products will be added. Tell me what to write here. Who can tell me what to write? 5, yes, minus 1, and then, all right. What's the next thing? Add. You see that? Can you not tell me what to write here? You tell me. What's the next thing? Why I'm doing this way? I'm doing this so that you can see what's happening first. Then later you can increase the speed. Don't try to do speed at the first time. That's not right. All together. So now we're finished with this row. Sorry, we're finished with this column. So we take it away. Then we take this row up. It's standing up there. We tilt it this way. Tell me what I'm going to write here. We take this row up. We tilt it to the left. What I'm going to write here. I write this thing there, like this. So I want to, now we're dealing with this column. I want something like that, please. This thing came from this column. We change it to a row this way. Now we're finished with this thing. We're coming here. I'm asking you, what should I write there? 1, 2, negative 1. Is that right? Okay. Then we now come, do you see? What's coming together? 0 dot 2. And then 1 dot minus 1. Here's a person who started to understand. Negative 1. You see what I did there? You can't leave plus and negative sign like that following each other like this. So then times, you have to say times what? Times negative 1 plus 2 dot 2. 1 dot minus 1. Dot minus 1. Yes? 1 dot 2. Are we together? Okay. Right, guys. Now what we need to do now, we need to simplify all these additions. And remember our answer we're expecting what? The identity, is it? Okay. So what do you do now? This is what we're going to do now. Let's check this. Check this. Check this. This is a 3 minus 3, which is a 0. And this is a minus 1 times 1 as well, which is a 1. So that's what? It looks beautiful. It looks beautiful. This is minus 3 plus 3 is 0. Then plus minus 1 times minus 1 is a 1. It has started to be beautiful. Don't you see it? Okay. Because I know what I'm expecting. Let's see what I'm putting here. This is a minus 3. This is a 3. Because this is a 1 and that a 3 plus this one is a 3. Then minus 3 is a 0. Let's check this one. This is a minus 2. This is a minus 1. Is a minus 3. This is a minus 1 and minus that is a plus 3. That's a 0. This is a 5. Oh, this is not a minus. Eh? Okay, minus. Okay, this is 0. So 5 here. This is a 2, a minus 2. Is this a minus 2? Minus 2, a minus 2, and this is a 5. This difference is a 1. And then this is what? It's minus 1, no 1, and there's a 5, and minus 5, 0. Then we're here. This is a 0, and this is what? A minus 1. It's a 1 plus a 0. This is 2 this is a 2, or this is 0, sorry. This is a minus 1, and this is a 1. That's a 0. And now what do we have here? This is 0, no? 0, this is a minus 1, that's a 2, it's a 1. So, bingo, we've got the inverse. Now we've got A here. We've got our inverse of A. And here, we've written our equation, system of equations is A, X equals B. Because of what we've done, we know that if we multiply here by A, this is an identity, and then multiply this side, the equation still balances. Altogether. Now, if this is an identity, you multiply the identity by X, we get X. Altogether. Then when we get here, we must get a solution which equals to this X. So what we're going to do, we're just going to take our inverse and write here X, and you know what is X is. X is X, Y, Z. Declare X, Y, and Z equals to. We're doing this, guys. This we've written down there, we know it's going to give us X. Now we multiply the right-hand side. We multiply by this matrix. We're going to say, and then at this point, I think you know what to do. You must multiply, isn't it? So let's multiply this and get the answers. Okay, I think that is a quick multiplication. What have you got there as entries of for these matrices? After multiplying this, what did you get? The first number get there? Minus. So now what we're getting here is that X, Y, Z is equal to this, isn't it? Yes or no? Now to give the solution to this equation, now we can say now, therefore, X equals to minus 2. We're using what? Equality of matrices. Y equals 5, and Z equals to 1. I trust the calculations were correct. That's it. If you want, you can quickly check here. If you put here X minus 2 and the Y is equal to 5, Y is equal to 5, that will be 5 minus 2, which will give you 3. And then Z is equal to 1, that will be 3 minus 1, which will give you 2. And this first equation is satisfied. You can check the rest. Is that all right? So up to that point, I think the question has been solved fully as it was supposed to be. So thank you for listening.